So imagine Europe just sliced right down the middle. One side is drowning in storms and wind. The other side is, well, it's frozen solid. That's the Great Eurasian Weather Divergence, and that's what we're diving into today. We've gone through a stack of sources on this major atmospheric split that's set to from December 26th right into the new year.
And this is not a normal winter pattern. You have to understand, this is more like a continental fracture. Yeah, you've got these two hugely powerful competing regimes. In the west, it's a high-energy maritime storm regime, and in the east, you have this entrenched, just severe continental winter. And where they meet, that's where the risk of systemic failure just skyrockets.
Okay, so let's get into the why. This wasn't just some random fluke. The source is pretty clear that the chaos on the surface, it's a symptom of something breaking way up high.
Exactly. The primary driver was a complete structural collapse of the stratospheric polar vortex.
Right, the SPV.
And that was triggered by a really unprecedented event, a major sudden stratospheric warming, or SSW, that happened back in late November.
So the Arctic gates basically just swung wide open. But how? I mean, what does a structural collapse up there actually mean for us down here?
It's a good question. Think of the polar vortex like a tightly spinning top. The SSW was like a massive high-pressure system, a counter-vortex, that formed about 30 kilometers up and just punched it. Hard enough to make it wobble and then completely reverse the winds up there from their normal westerly flow to an easterly one. And that reversal is what physically shoves all that pent-up Arctic air south across Eurasia.
And it's not just the stratosphere acting on its own. The sources link this back to the tropics, these teleconnections. Why should we care what's happening at the equator when we're talking about an Arctic blast?
Because the tropics set the stage. This whole event, this SSW, it happened to line up with a weak La Nina and critically the eastward phase of the quasi-biennial oscillation, the QBO. And when the QBO is in that phase, it historically it supercharges these cold events, makes them more likely and makes them last longer. It basically primed the atmosphere for this exact kind of chaos.
Right. So now that we get the why, let's look at the impact on the ground, starting right in the middle in Central Europe, the collision zone. This is where they're talking about a solid ice shell risk.
Yeah, and that's terrifying. It comes from this really complex vertical layering in the air. So imagine you have this incredibly cold air mass sitting at the surface, maybe -10 Celsius.
Okay.
Then warmer, moist air from the west, the maritime stuff, it flows in over the top of that cold air, and it falls as rain.
Into the freezing air.
And that rain instantly freezes on contact with every single surface. It creates a thick, heavy shell of solid, clear ice. It brings down power lines, coats roads, stops trains. It's incredibly destructive.
Wow. Now contrast that with Eastern Europe and Russia. They're not in the collision zone. They're fully inside that deep freeze.
Oh, absolutely. Plunging temperatures. We are talking extreme morose, especially in places like North Kazakhstan, with forecasts down to -35 Celsius.
-35.
The operational strain is immense. You're looking at peak energy demand, infrastructure stressed to its absolute limit. But there's a fascinating sort of hidden benefit here.
The benefit to this.
This kind of sustained, brutal cold is incredibly effective at killing off overwintering agricultural pests.
Wait, really? So amid all this, this meteorological chaos, nature's doing a bit of pest control.
A very morbid kind of spring cleaning, yes. I doubt the energy grid operators are celebrating it, but it's a real effect.
I can imagine. Meanwhile, Western Europe is facing something completely different, right? A transition.
A really difficult transition. They had massive rainfall earlier in December. Storm Bram dumped over 100 millimeters in some places, so the ground is totally saturated. Flood risk is high. And now...
Now it shifts.
It shifts hard. A Rex block sets up in the atmosphere.
Which is what exactly?
Basically, a huge atmospheric traffic jam. It locks the pattern in place and starts pulling in this dry, bitter, easterly wind over that wet ground. So you get widespread frost, black ice, and you combine that with winds gusting 45 to 55 miles per hour on the coasts. It's arguably more dangerous for travel than a simple snowstorm.
So we've tied the atmospheric dynamics to the regional impacts. But what's the big picture here? The sources keep coming back to climate change, specifically Arctic amplification.
That's the underlying story. The Arctic is warming 4 times faster than the rest of the planet. That reduces the temperature contrast between the pole and the mid-latitudes, and that makes the jet stream weaker, more wavy.
And that waviness is what allows these events to happen.
It's exactly what allows these big high-pressure systems to wander north and disrupt the polar vortex so violently. Our Arctic air conditioner is essentially broken.
Okay, so to wrap this up, let's leave you with a final thought, one that builds on all this. Let's look at the South Caucasus. They're facing both extremes at once, but on different timescales.
It's a really critical point. Right now, they are bracing for over 100 centimeters of snow in the mountains, a deep freeze. But that massive snowpack, combined with the region's rising temperatures in general, just accelerates the long-term crisis of glacial melting.
And that's already happening.
Dramatically. Look at Azerbaijan. It's lost 77% of its glacial mass since 2000. These regions are staring down the barrel of peak water, leading to severe summer water shortages.
So here's the thought. How do you manage the immediate operational nightmare of a deep freeze while at the same time confronting an existential decades-long crisis of water security? Managing both crises at once. That's the real deep dive.